Okay, moving on. Next comes regular expressions. Did you do a lot of regular expressions in scripting? Yeah?
Not a lot, but
A little? Okay, well, unfortunately I'm not going to get much into it here, because again, we're about data structures, not scripting. So most of your regular expressions that you learned will work in the command line as well. So you have the star, or I like to call it the splat, all possible combinations. So we're back here, quick 2, I did an ls, I have file 2, file 3, file. If I were to do a cat, I could do cat on file.txt and that just prints file.txt, or I could do cat on star, and what's that going to concatenate? All the files, right? There we go. Question mark matches one exact position, so star means 0 or more, because it could be, for example, if you do des star, desktop description matches, also des matches as well. But if you do question mark, it has to be one exact character in that position. So des question mark, desk, des9 would work. Des by itself would not. Description, of course, would not as well. So ls-al star.ps, you're going to display all your .ps files. Cat on anything that has 2 characters and then go. How about that last one? More star A star B. Question mark. What is that one going to work with? Louder. I just didn't hear you. And then something after, but what it specifically has to be after the B?
Well, it has to be some character.
One character.
Yes.
Yeah. How many? It has to be exactly one character.
It's
Right.
more.
Okay. When you use the brackets, it means anything from the list of it. So if you did bracket MSOON, it means moon or soon would be in there, because it can either be an M or an S, but it can't be anything else. You can also use a dash, which means A through P in the alphabet, followed by ount afterwards. So ount, bout, count, down, etc., all the way up to pound. All right. Okay, this is where grep comes into play. You will probably want to learn this. It will help you search your code. Adam might be able to help you with it. Global or get regular expression and print. All right. That's kind of confusing. All right, let me show you what's going on here. You're really looking for a pattern inside of some file name. And I think this makes more sense if we just go to the examples. So let's go up to that grep directory. I'm going to cat the grep file. If I do grep the and then grep file, that means I'm looking for the pattern the inside of grep file, and I'm going to print out lines that contain the. So what's going to be printed out? So turn off the light. Yep.
Will we count the Z in then?
Yes. As well as, what was the other one? The C. Yeah, so THE and then counts. Because it's just looking for THE. It doesn't, it can be anything before or after it. It doesn't care. Okay. Very good for finding out where did this function go? Where did I declare this variable? Did I put a comment in here? I hope I did. WN, that should be word and number. So let's see. Okay, so W means I'm looking for the word THE, which is why then no longer matched. And N will tell you the line number it's on. So it's line number 2 is so turn off the light, and 5, line number 5, and you will swim through the sea. V. I don't remember what V did. Let's find out. I wonder what V did.
So we'll just
Is that the one after it?
everything that doesn't have.
Yeah.
Ah, yeah. We'll do grep. Output the version. No, we don't want that. Invert match. Yep. Awesome. Okay, grep, here we go. Grep, let me clear this so it'd be a little cleaner what's going on. Grep.nd, do I need space? Oh, no, okay, fine. Grep file. Y'all probably don't know what the dot means. The dot is one character before nd. It's the question mark. It's just a little different. So, and, what else do we have? No, that's ND, as during the I don't see the second one.
Wonderful.
Ah, thank you. Good catch. It's in wonderful. Okay, caret. Oh, caret means it has to start this way. So if it has to start this way, which one is it going to be? Oh, I hit enter. So it's only going to print off the lines that start with something and then nd after that one character. Let's see. Oh, swing. All right. Let me make sure I do this. SW star NG. All right. Which lines? Remember, the lines are up here. I don't know if this makes it easier to read or harder. Probably harder. You're looking for a line that has the character SW followed by any number of characters and then an NG. What?
That's what I said.
Oh, it is? Yeah, sorry.
Oh, never mind. You said it on it.
I think I heard you say something else. But yeah, it's okay. So which line is that? Yeah. Actually, it should have found that one. Uh-oh. We're having problems. Oh. I forgot the dot. Actually, this should be dot star is what this really should be. Yeah, this slide is backwards. It needs to be dot star. Because what it's saying is SW followed by dot any number of characters NG is actually how it's written. That slide is wrong. Who wrote it? All right, grep, capital A through D. All right, this one should be pretty straightforward. It's only going to be the last one. Perfect. And okay, we're done with this. I do invite you to practice these. These are going to become very useful, not just for this course, but actually throughout your whole career. A lot of people, this is used a lot. A lot of people go overboard, so try not to solve every problem with regular expressions. They solve some things very well, namely input validation. Other things, not so well. Don't try and write a program in regular expressions with this app. So dot matches a single character. Solid brackets, any character in the closed brackets, just one of them. If the first character is after the bracket is a caret, then it's any character not in the enclosed brackets. So all that's saying is that with your solid brackets, you have two versions, either everything in it or everything not in it. All right. Star or slat may follow any character and denotes 0 or more. It doesn't have to be 1. It has just 0 or more. It doesn't have to be any of them. Caret has to match the beginning, and $ matches the end. Okay. Any questions on grep? It's going to be a lot. The best way for you to learn it is just practice, practice, practice. It's going to really help you out. I'm not giving a lab on this, but it's going to help you out, not just in this course. Okay, a couple things about the Linux environment, just concept-wise, so we know what's going on. The GUI lets you log in text mode. You have commands to log out as well. You just type in the word exit. Like over here, I can type in exit, and it goes away. Another way to do it is if you do Control-D, it does the same thing. At least on my system. Hopefully it does that on Windows, Bash on Windows as well. All right. Just because you're logged out doesn't mean the system is off. Even if all you have is a terminal, I wish I could show you the machine in pure terminal mode, but if I did, I would no longer be recording. So, and then it breaks everything else, so I'm not going to jump over right now. Time? Tell the time in hours, sure. Oh, time, that's for a program. You'll do time and then maybe some program, and it'll tell you how long that program took. So for example, if we did sleep for 1 second, that pauses for 1 second. So you could do time sleep 1. How long did it take to sleep for 1 second? It looks like 1.01, so pretty close. Okay, shutdown. We're actually talking about shutdown here. I just went off on a tangent with time. You can tell the machine to shut down. There's different parameters, reboot, halt, or cancel the shutdown. You can actually tell it to reboot at a certain time if you want to as well. Reboot just does it. Manual, we've talked this a little, helps a lot with finding out what a command does. Tons of user management tools. User add is how you add a user. D will display it. G gets some defaults. You can delete a user with user del. Password can change the password as well as the password of a user, but note that you have to be root or a special user in order to change the password of someone else. User mod will change the permissions or what they're allowed to do, maybe their default shell or their default UID. That's your user ID on the system, as well as many other things. Here it says CSH. You can have different shells. The one we usually have is called bash, which is called born again shell. How did it get its name? Well, the first one was called shell. Then a guy named Born created the Born shell, and then a bunch of people improved it, so they just called it the born again shell. There is a GUI for it. If you feel so inclined, you can use Google to find it. Groups. Has anyone talked to you about groups? Group permissions? There are different ways to do security on systems. A very common Unix way that's been around since the beginning is to have a group. So everyone has a user ID, and they can be a member of 0 or more, well, they're a member of their own group, because whenever you create your user ID, you have your own group. So you can be a member of other groups. So the idea is that if you want to give permission to a lot of people for something, you add them to the group, and then you have that group have permission to do something. What this implies is that each file has group permissions as well as user permissions as well as global permissions. So there's 3 sets of permissions on every file inside of Linux by default. If you're running a different flavor of Linux, SC Linux, there's a couple other things you do, but at the base you always have 3 sets of permissions. And one of them is the group. All right, we don't care about that. So here we go. If I ever did an ls-l, you notice it had all that read or RWX. That stands for, does it tell you? Read, write, execute. Read, write, and execute. Okay, R for read, write, and execute. Let me go over and see if I can give you a better example. CSU courses CCI 315. Last code. Quick 2. ls-l. Okay. Ooh. Owner, read, write, just read and write. I can't execute it. Group can read it, and global, everyone can read it. That's what's going on right here. So, there are different ways to think of it, but in general, you got to think of it as a number, because, for example, if I were to do chmod 600 on the file, and then I did an ls-l. Hang on, okay. That file I did now has read write for the owner, but no one else can read it or write it. So what were those numbers? These are the numbers that Linux uses. Well, each digit represents read, write, execute, where read is 4, write is 2, execute is 1. So you sum up what you want. So with 6, what did 6 mean? Read and write, right? 4 plus 2 is 6. All right, amazing. And 0 means no permissions. so you can't do anything. Awesome. Okay, some more examples just to make sure this is in everyone's head. If let's see, before I had read, write, execute, read, write, execute, read and execute on archive. I chmod it to 7.5.4. 7 means, again, read, write, execute. 5 is 4 and 1. If you recall that as read and execute. And then 4 is just read. So the owner has read, write, execute. Group has read and execute. And the university, aka global, has only read. Top secret, read, write. User, read on group and read on global. Probably not what you want on a file named top secret. So, yes.
Here in the last one, it's a 665, but why is there no X there?
Why is there no X there? That's a great question. There should be an X there. Good catch. 600, 6 read write, and then no one else can read it or write it. Publicity, that should actually be chmod 664. Is really the change that needs to happen here. So read write only to owner, but you want everyone to be able to read it. So if you did 664, it'd be read write, and then just read for everyone else. Okay, password file. Oh, any questions on this? So chmod is how you do things, that's how you help it. Why is this a terrible idea? Let me make this.
Everybody can read and write to it. Every single file. Under the directory.
Right. Please try to avoid doing 777 when you can. I understand every once in a while you're like, okay, I'm done. 777, blow it. You have permission to do everything, but try not to do that. You'll have especially if you're a sysadmin. All right, passwords are, well, okay, let me rephrase that. The password file is etc password, and it's the database for all the users. It's formatted username, password, UID, GID. UID is the number of your user ID. The GID is the number for your group ID. And then usually the GCOS, that's like, my name is Paul West, blah, 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 blah. Home directory is where your home files are, and then shell is the program to execute when you log in, aka, well, most of the time it's bash. No login means they can't log in. You look up here, a modern password file has X where the password would normally be. That's because in order to make things a little more secure, it's in a shadow file, which is harder to read under Linux. So, modern Linux, it's just an X, which means look somewhere else. All right. How do you become root? You're going to need to be able to do this. su-root. You have to then put in the root password to become root. If you are part of the sudoers file or part of the sudo group on most modern Linux systems, you can do sudo su, which runs the command su as root, but then you only have to put in your own username. For bash on Ubuntu on Windows, it's the second command you're going to want to use.
You should do that.
Don't run as root unless you absolutely have to. All right, login, you're going to learn all this in OS, so we're going to skip that for now. Quota, I could set a quota if I wanted to. All right, now you actually have everything you need for Lab 1. Hint for Lab 1, well, I said you have everything you need. That's a lie. You have everything I'm going to present for Lab 1. Part of Lab 1 is going out and trying to research how you do a couple of things in Linux, because it's very common for, hey, how do I do this command? Google it real fast. But most of these commands you can be able to figure out from these slides. Good. Any questions? No questions? All right.